We're going to do the products of that reaction. In the previous video, we have studied different types of nucleophiles over to aldehydes and ketones. Among them, we did hydrogen with the carbon nucleophiles and oxygen nucleophiles. And we did the acetal formation. So let's remember what that is this is your carbonyl compound, and you have, say, for example, here, acetal. When you make it react with alcohol, 1 mole of, say, here, in here to here, an alcohol, and you have acidic conditions, you will create first an intermediate called acetal, and then after several steps, which we saw, but we're going to do it again today with this molecule. But the final product, when we have, say, excess of alcohol, is an acetal. So let's do that again. This reaction is important because when we're using this diol, this reaction is used to protect carbonyl groups and then do other chemistry. So let's work to that. Our first step, since you are under acidic conditions, will be protonating the oxygen at the carbonyl. So you're having that. Next step will be the nucleophilic attack. And let's remember that the acid is actually making the carbonyl carbon more electrophilic. So it is acting as a catalyst. So here we have then a nucleophilic attack over, and okay, and this is what we're doing. Now we have, this is the rest of the molecule, right, that we are attacking with. So that's formal positive at the oxygen, and this is the rest of the molecule. So at that point, I still, if I do a proton transfer in this case, since we are under acidic conditions, you can have the alcohol or even water to act as a base to remove that extra proton. So that's a proton transfer step. In here you will have OH, and now you will have O and this. And all of that we can call R. So that is an acetal. That's the structure, acetal. Now, as is, we're going to do another proton transfer step. The formation of the acetal involves dehydration. We're going to lose water. To do that, we need to protonate here. So with hydronium, let's draw it explicitly here. I will have a lone pair here getting 1H. And I will form the protonated acetal. So there's one. And now what happens is we're going to make an intermediate like similar to these like we did in other reactions before. So if we move this, now water is a good leaving group, and we will be making an intermediate that now resembles that. But this time we're going to have O double bond in this is carbon and OH. Here you will have a formal positive. So you can notice this formal positive oxygen with a double bond. That makes a carbon electrophilic. So next step is nucleophilic attack. Over here now electrons go back to the oxygen, and I will have O, this, and here I will have an extra H in the bond over here. So that oxygen is formal positive, and I need another proton transfer step. So here, let's say we have another molecule of the alcohol, a diol in this case, but I'm just going to draw it like so. So that is a diol. We're going to get that proton. So it is a proton transfer step. And my final product is in this form. So it is an acetal, but this time it's a cyclic acetal. So the important thing here is that these steps are reversible. And why is that important? Because the acetals can hydrolyze back to the carbonyl. So I'm going to just draw arrows all the way. So meaning these are like that. So under acidic condition, you can have the acetal go back to the ketone in this case. So all those steps being reversible. But that reversibility is under acidic conditions. But if you have this molecule and do reactions, other reactions, under basic condition, then the acetal is stable. So we're going to say that here. Acetal is stable under, say, basic conditions. That will allow us to do other things. We're going to have an example of that. But again, acetals can be hydrolyzed back to the ketone or the aldehyde, whatever you started with. So in this reaction is important because since we can form this cyclic acetal and it is stable under basic condition, we can use it in synthesis to protect a carbonyl group. And that is very useful. We can do other chemistry. And this is what we're doing next in another video.